most satisfying machines, and ingenious tools. Number 10. Hydraulic riveter. A hydraulic riveter is a tool that uses hydraulic force to drive connecting rivets into metal components to secure them together. Small metal components known as rivets resemble unthreaded bolts. When a rivet is run through a riveter, the bucktail or thinner straight end flattens and expands to create a strong connection. Rivets are available in a wide range of sizes for a variety of uses. Rivets, a method that predates welding and bolting, are frequently used on automobiles and in early 20th century buildings. Even though more advanced methods have replaced them, rivets are still often used in a wide range of manufactured goods, including bridges, mobile phones, and commercial aircraft. A tool with the ability to apply a significant amount of kinetic force is necessary to install a rivet. Small rivets can be manually inserted using a hammer or a device known as a bucking bar. However, larger ones demand the use of a specialized riveter or rivet gun. Riveters can be powered by pneumatics, hydraulics, or an electric motor, among other things. A riveter can complete a rivet in several different ways in addition to the force that drives them. Number 9. Tree baler. A tree baler is a device that bundles trees for simpler transportation and storage. Trees that have been wrapped take up much less room and are less prone to sustain harm during transport. The device's purpose is to eliminate the need for labor-intensive process of hand-tying individual trees, which is most frequently used at commercial nurseries. Tree balers force a tree through a funnel, crushing the branches close to the trunk in the process. The branches are then wrapped or tied by the baler to keep them in a compact state for storage and transportation. Simple machines need 2 people to push the tree through the funnel and wrap it. They are often operated manually. Both tasks are performed using a motorized baler, which can bale more than 100 trees each hour. Instead of twine, a manual baler may enclose the tree in a plastic netting to keep the branches crushed. This type of baler is frequently used to bundle Christmas trees for customer carriage and retail sales. Trees are not compressed as tightly by manual balers as by mechanical ones. Number 8. Heat sinks. To improve the operation of electronic equipment, a heat sink is a heat exchanger that operates passively to transfer the heat produced by a device to a more fluid medium such as air or liquid. Computers and semiconductors are the 2 electronics that use heat sink the most frequently. A tool or substance called a heat sink is used to absorb any extra heat that a machine may be producing. Modern electronics need controlled temperatures and conditions to function at their best, which is why a heatsink is so important in its design. A device's performance might drop off quickly when it overheats, and in more extreme circumstances, it may even lose power and pose a safety risk. By spreading heat into the environment through the air or a liquid coolant, depending on the needs and complexity of the machine, the heatsink aims to reduce the likelihood that this may occur. Number 7. Machine press. A forming press, often known as a press or just a press, is a machine tool that uses pressure to modify the shape of a workpiece. An operator of a forming press is referred to as a press tool setter or tool setter for short. It typically comprises a simple rectangular frame with a bottle jack or hydraulic cylinder to apply pressure to a workpiece using a ram, which is generally composed of C-channel or tubing, used commonly for routine shaping work in machine shops, auto repair shops, garage or basement shops, etc. Standard shop presses have a pressure range of 1 to 30 tons, depending on size and structure. Common names for the lighter-duty versions are arbor presses. A shop press is typically used to press interference-fit components together, such as gears on shafts or bearings and housing. Number 6. Ballast. Ballast is a material that stabilizes a machine or a building. In addition to cargo, a vehicle can be stabilized by adding ballast. This is typically done using ships, a balloon or airship's gondola, or both. A boat, ship, submarine, or other floating structure may contain a ballast tank, which is a container that holds water. Water must enter and leave the ballast tank to balance the ship. In a boat on the water, ballast is a weight that is kept below the water's surface to balance the effects of weight above the water surface. The ballast may be eliminated totally or distributed differently throughout the vessel to change how much it affects how the vessel moves. Sailboats employ sailing ballast to add momentum and counteract the lateral pressures acting on the sail. In strong gusts, vessels with insufficient ballast tend to tip or heel excessively. The boat would capsize if it has too much heel. A sailing vessel would load little to no value ballast to keep it upright if it had to travel without cargo. When the cargo was loaded, some or all of this ballast would be thrown away. Number 5. Braiding machine. A braiding machine is a tool that weaves 3 or more strands of yarn or wire together to produce a range of materials such as rope, reinforced hose, covered power wires, and some varieties of lace. Metal wires, leather tapes, natural and synthetic yarns, and other materials are used in braiding. Bobbins of thread move left and right along pseudo-synoidal tracks in a horn gear braider. The spool carriers that the bobbins are mounted on are powered by a series of horn gears. Bobbins are moved between the slots of adjacent gears and horn gears, which are notched discs driven by spur gears below them on the same shaft. The track plate that the bobbin carriers ride on is underneath these gears. Number 4. 3-axis machining. Rotary filing, a milling technique that used the X and Y axes as its 2 axes, give rise to 3-axis milling. In 3-axis machining, the workpiece is stationary and the cutting tool mills the part while moving along the 3 axes. One of the most popular methods for making mechanical parts is 3-axis machining, which can be used for automatic or interactive operation, milling slots, drilling holes, and cutting sharp edges. Material can be removed in these 3 axes, which are represented by back to front, side to side, and up and down, thanks to 3-axis machining's simple operation on just 3 axes. Number 3. Paper cutter. A paper cutter, commonly referred to as a paper guillotine or just a guillotine, is a device that is frequently found in offices and classrooms that is made to make straight cuts to multiple sheets of paper at once. Paper cutters come in a variety of sizes, often ranging from 841 millimeters in design workshops to around 30 centimeters on each side for office use. The surface will typically have a ruler across the top and a grid painted or etched on it. It must, at the very least, have a flat edge that the user can align the paper with to pass it underneath the blade at a correct angle. To ensure stability while in operation, it is often fairly heavy. Number 2. Dental milling machine. A dental milling machine is used to mill and grind 3-dimensional things utilizing a computer-guided machine from a digital file. Dental crowns, copings, bridges, removable dental prosthesis, temporary prosthesis, full dentures, implant abutments, etc. are all made with a dental milling machine. Dental CAD/CAM milling machines use various market-available blocks and blanks made of various materials according to the prosthetics requirements. Number 1. Laser cleaner. As excellent alternatives to conventional surface cleaning techniques like chemical cleaning and abrasive blasting, laser cleaning systems are gaining popularity. Laser cleaning is becoming more popular among manufacturers who need clean metal surfaces since it is economical, ecologically safe, and yields more reliable results. Lasers can remove pollutants without harming the substrate, whether it be for rust, paint, oxide, or coating removal. Industrial laser cleaning applications benefit from the little maintenance required by the non-contact nature of the laser cleaning process. Workstations for laser cleaning can be fully operated manually and are 100% safe for users without protective equipment.